You are looking at a function. It does one simple thing, process an order. But to reach the line that actually processes it, you have to read through 5 levels of nested if statements, each one indented further to the right than the last. By the time you find the happy path, you're so deep inside the pyramid that you have forgotten what the function was supposed to do. This is the arrow of doom, and guard clauses are the way out. In the next few minutes, you will see exactly what they are, why they matter, how to write them, and when to stop. You have seen the problem, now here is the side by side. On the left, the nested version, 6 levels of indentation before you reach a single line of real work. On the right, the guard clause version, every failure condition is handled at the top of the function, the failure paths exit immediately, and the happy path runs flat at the first level of indent. The shape is completely different. The left version makes your eye travel diagonally down the screen. The right version reads like a list of preconditions followed by the actual logic. Same function, same behavior, radically different readability. So what exactly is a guard clause? It is a conditional check placed at the top of a function that exits immediately if a precondition is not met. There are 3 parts. First, the precondition check, a single condition that tests something that must be true before the function can proceed. Second, the early exit, a return or a raise that leaves the function the moment the check fails. Third, the happy path, the main logic of the function which only executes once every guard is passed. Think of it as a bouncer at a club. Bad inputs never make it through the door. The people who do get in can move freely inside without extra checks on every corridor. Guard clauses solve 4 concrete problems. Readability, readers see failure cases first, then success. The function declares up front what it refuses to handle. No one has to track nesting depth across 50 lines to understand the flow. Testability, each guard is a single independent condition. 4 guards give you 5 easy test paths, not 16 nested combinations. Mock frameworks need fewer stubs because failure paths exit before reaching dependencies. Maintainability, adding a new precondition is 1 line at the top. Removing a guard is a single deletion, no bracket archaeology. And cyclomatic complexity, nesting multiplies independent execution paths through the code. Static analysis tools flag deep nesting for good reason. Lower complexity correlates directly with fewer bugs and shorter code review cycles. Guard clauses appear in 5 common shapes. The null check, if user is none, return none, most common pattern in any language, prevents null reference cascades downstream. The invalid state check, if not account is active, raise an error, ensures the object is in a valid state before you call any methods on it. Type or format check, if the value is not an integer or float, return, validates input before arithmetic or parsing. The permission check, if the user cannot edit this document, raise a permission error. Authorization guards are idiomatic in web framework controllers and service layer methods. And the empty collection check, if items is empty, return an empty list, avoids iteration over nothing and makes the empty case contract explicit to callers. Here is the refactoring process step by step. Take the nested version, 6 levels of indentation in send email. Step 1, invert each condition. Instead of checking the success case, check the failure case. Step 2, return or raise immediately inside the guard body. Step 3, remove the now unnecessary else block. Step 4, repeat for every nested condition until no nesting remains. The 4-step rule is invert, exit, delete the else, repeat. When you are done, the function should read as a list of rejections followed by a single happy path. Every line of meaningful work is at the same indentation level. No diagonal eye tracking required. Guard clauses can become anti-patterns when misapplied. Too many guard signals a validation waterfall. A function with 12 guards is doing 12 different jobs. The fix is separation. A validate function checks all conditions. A process function assumes clean input. Silent exits are dangerous. Returning without explanation leaves callers with no idea why a call failed. Use return codes, result types, or exceptions to communicate failures explicitly. Some guards are actually business logic in disguise. Branching to return different outputs is not the same as guarding against invalid input. And guard clauses only work inside functions because they need a return target. In a loop body, use continue or break instead of forcing the pattern where it does not belong. Mental model is 1 sentence. If a precondition is not met, exit immediately and never defer to an else. Guards go at the top of the function, 1 condition per guard, the happy path last and unindented. Every mainstream language supports early return. Python, JavaScript, TypeScript, Java, Go, Rust, all have the same primitive available. The code smell that tells you a guard clause is needed is the long if block. If you see if X and then 50 lines of work before the corresponding else, invert it. If not X, return and the 50 lines move 1 level back to the left. Guard clauses are not a replacement for polymorphism or strategy patterns. They are not permission to skip communicating errors. They are the smallest possible tool for the specific job of keeping precondition checks flat, visible, and testable. Thanks for watching.